A group of Arctic worms are using bacteria in a new and really interesting way, and we're going to talk all about it on today's episode of Short Stories of Bacteria. Hey everybody, welcome back to another episode of Short Stories of Bacteria. I, as always, am your host, Dr. K, and I'm here to guide you through another story chronicling the lives of the tiny and the infamous, and that, of course, is the incredible and the amazing bacteria and all such related organisms. I have a really cool story to tell you guys today about worms and bacteria and the Arctic and how all three of those will blend together. We're going to jump into that in just 1 second, but first, don't forget to hit that like, share, subscribe button if you're listening to this on YouTube, or if you're listening to this on some other podcast medium like Spotify or Apple Podcasts. Don't forget to hit the follow button to help support the podcast and to help support the channel. Okay, let's jump into the actual science for today. I guess the best place to start here is to quick recap, because I know we've talked about this a whole bunch of times on the podcast already, but it's important to recap that bacteria, they're super, super useful for protecting us from a number of different things. Typically, we talk about this in the context of pathogenesis. So, for example, you and I have a skin microbiome that's really, really good at protecting us from any types of skin pathogens that are trying to attack us. We talked about how we actually have a microphagome, so a bunch of phages, bacteriophages that we have on our body that protect us from other bacteria. We even talked a little bit about, maybe you guys remember this, we talked a little bit about a frog and about how there's a frog that is currently being overrun by a specific type of pathogen, but you can actually protect that frog from the pathogen by giving it a certain type of bacteria, and then the bacteria develop weapons to fight off this attacking fungal pathogen. So there's a whole bunch of different instances of how bacteria are being used, or microorganisms are being used as a way of protecting ourselves from other microorganisms. Now, as I mentioned, we've typically discussed this in terms of pathogenesis, protecting us from other organisms. But we haven't really talked about this in terms of protecting ourselves from the environment. So is it possible that we could use microorganisms as a way of protecting ourselves from the environment? Now, you may be aware, because it is the start of February, that we are still in the cold season. It is quite brisk outside where I'm at. And indeed, it would be difficult to find a more cold part of the world than the actual Arctic part of the world. So there are tons of, in spite of the fact that it's extremely, extremely cold in the Arctic and the Antarctic, there are some organisms that are able to survive out there. One that comes to mind just right out of the gate are like the fish that survive in the Arctic and the Antarctic. Now, these fish, they have to have some way of surviving because the waters of the Arctic get really, really, really cold. Obviously, they don't get to actual freezing because then it would not be like liquid water, it would be ice. But it still gets really, really cold to the point where the temperature is way, way too low for anything to survive without having some kind of adaptation that allows it to survive really, really cold environments. Now, a lot of the fish in the Arctic, they develop things called antifreeze proteins, or AFPs. Now, what AFPs do is they prevent the growth of ice crystals. And the reason why this is important is that ice crystals are extremely, extremely sharp. And as ice crystals are formed, those sharp edges on the ice crystal can poke holes in the cell membrane and eventually just destroy cells. This is actually why if you take some kind of fruit or vegetable and put it in the freezer and then freeze it and then take it out and thaw it again, it's going to be a lot mushier than if you just plucked it right off of whatever plant you initially get it from, right? The reason why is that when you freeze it, all those ice crystals are formed and they start destroying the cell walls of plants. And because of this, that makes them all mushy, and there's a whole bunch of dead cells that are just present because they've been frozen. Now, antifreeze proteins, what they do is they protect or they prevent the growth of these ice crystals. And in doing so, they protect the animal from actually getting killed or losing a whole bunch of cells every single time you get to this really, really low temperature. Now, the example that we just gave was fish. How do fish survive in the Arctic? But as it turns out, there are other organisms that survive in the Arctic, one of which are a group of worms called polychaetes. Now, polychaetes, they're actually really, really interesting. I was looking them up earlier. They're an extremely diverse group of worms. They're primarily marine worms. They primarily live in the water. And they have a whole bunch of different characteristics. I have pictures over here of some of them are glowing. Some of them have these little antennae. A lot of them have these little protrusions or bristles that stick out from the side, and they actually can use those for not only movement, but they could also use them for breathing. So really, really wild, diverse group of worms. Some of them actually end up living in freezing cold temperatures. Now, how is it, unlike something like for example, we have goats at our miniature farm, Dr. K's miniature farm. We have goats that have a big old coat that can cover themselves and they can protect themselves from the cold that way. We talked about the antifreeze proteins that are present in fish. But worms, these polychaete worms, they don't have anything like that, right? So they have to have some other way for them to survive these really, really cold temperatures. Okay? They don't have any way of protecting themselves. So how is it they actually survive this? Now, it's been theorized, this is actually where we get into the paper for today. This paper came out it hasn't been quite a year. It came out in June of last year. And it is out of a Polytechnic University in Ancona, Italy. So good job, Italy, doing some good work over there. And what they were doing, they had this theory that somehow maybe bacteria could be protecting these polychaete organisms from dying because of the cold exposure. Now, they hadn't really demonstrated it, but they're like, okay, let's do a little bit of digging on the microbiomes of these polychaete worms, and then we'll see if there's any clues as to how this actually works. So they took a look at the microbiomes of these guys, and they found a couple of different bacteria, and two in particular called Myothermus and Anoxibacillus. Now, real quick side quest on Myothermus and Anoxibacillus. Myothermus is actually not typically found in really cold environments. The first Myothermus bacteria was actually found in a thermal vent, so it's a really, really warm environment. You don't usually see them in cold environments, but they're found in and around these polychaete worms. The other one, Anoxibacillus, is also found typically in more temperate environments, so you don't typically see these guys in cold environments. But for whatever reason, these guys were attached and found in the microbiome of these polychaete worms. Now, once they looked at these bacteria a little closer, they found that when the bacteria were in these cold environments on these polychaete worms, they did a whole bunch of really, really wild things that the worm could actually then use as a way of protecting itself from the cold. So, for example, they had the ability to produce these antifreeze proteins that I mentioned before. They were able to produce proteins called cold shock proteins. Cold shock proteins are a type of protein they're not very, very well understood as far as I'm aware. But the thought is that they'll bind to things like DNA or RNA as a way of protecting it or preparing it for cold exposure. They made these ice-binding proteins that I mentioned a second ago, so it's very, very similar to the antifreeze-binding proteins. They prevent making larger crystals of ice. They were also making these things called cryoprotectants. Now, cryoprotectants, right, these are really, really useful in preventing the freezing of a solution, right? So you can put cryoprotectant into a solution and that'll prevent it from freezing. This is extremely, extremely useful for any old eukaryotic cell, any old cell, because remember, the interior of the cell is composed of the cytosol, which is a liquid, and so that can also freeze. And so these cryoprotectants that the bacteria were making could then be used as a way of preventing that solution from actually freezing. Now, that's about as far as the researchers actually got. They identified these bacteria and they figured out that they're producing these different useful molecules, but they hadn't quite demonstrated that the worms actually utilize these molecules as a way of protecting themselves. That's the current hypothesis, but it hasn't been quite demonstrated yet. So we still got a couple kinks to work out in terms of the overall theory, but the going hypothesis then is that the worms are able to use these molecules the bacteria are producing as a way of protecting themselves from this frigid cold. Now, there's obviously a whole bunch more questions that emerge out of this. Obviously, we want to finalize the details on this overall theory. But is it possible then, if bacteria are able to produce these antifreeze molecules, is it possible that we could use them for our own devices? Could we use it on larger animals? Are there some other ways that we could use these really cool molecules? Could we harvest them? Could we harvest the bacteria as a way of protecting any old thing from breaking down in the cold? So there's a whole bunch of different questions that emerge out of research like this. But most of all, I think it's just a really, really cool example of how bacteria, not only do they protect us from something like a pathogenic environmental concern, but they can also protect us from just like changes in temperature or changes in overall harsh environments. So really, really cool story. Let's quick recap where we are. Number one, it's freezing cold outside right now, so hope you guys are staying warm with all of this. Number two, in spite of the fact that it's freezing cold outside, there are some worms, polychaetes that we talked about, that have to come up with ways in order to survive the cold environment. We talked about number three, these worms, they have a microbiome like everything else, and so they have tons of different bacteria, two of which we talked about, myothermus and anoxobacillus, aren't typically associated with freezing cold environments, but they're present in the microbiome. And then finally, number four, these two bacteria in particular are mass producing tons of molecules that are useful for the worms in terms of surviving these cold environments. So anyway, again, really, really cool story about how organisms can use bacteria as a way of protecting themselves from harsh environments. It's another good reminder to thank your microbiome, because maybe it's helping you in ways that you don't even know yet. And I'm sure that's the case. It's the case for me. I'm sure it's the case for plenty of other organisms around the world. But anyway, that's all I have for you guys today. Thank you, every single one of you guys, for tuning in. And I'll see you guys again next time on another episode of Short Stories of Bacteria.